Welcome back to linear algebra. Let's jump into Anki. Is it possible to multiply two invertible matrices of the same size and obtain a matrix that is not invertible? No. State 5 results that are equivalent to the statement that an n by n matrix is invertible. 5 statements that are equivalent. The reduced row echelon form of A is ax equals 0 only has the trivial solution. A can be expressed as a product of elementary matrices, and ax equals b has exactly ax equals b essentially has a solution for every b, and for ax equals b there's exactly one solution for each the different b's. All right. Let A and B be square matrices. State two equations, either of whose validity guarantees that B equals the inverse of A. Two equations. A times B equals I, B times A equals I. All right, that's it. So I'm gonna grade what I did yesterday, and then we're gonna jump into the next unit 1.8 right now. So talk to you in a sec. All right, we got all of the problems right yesterday. It's time to begin 1.8. What is this about? Introduction to linear transformations. That feels big. So I'll be back to recall what I learned in a little bit. All right, I read the first section of this 1.8, and then I actually worked on working on some of the 1.7 Anki flashcards. So what did I learn from 1.8? Linear transformations. So linear transformations, I believe, have to do with transforming one vector into another vector via matrix multiplication. R to the power n is the set of all vectors in of real numbers, something like that. This is an important concept that we'll learn more about. But I think R to the power n is basically column vectors, every column vector with n rows. Then we talked about some other things, column tuples and vector forms. So a tuple, right? An n tuple, say an ordered pair, an ordered triple, say an ordered tripled. Example, x1, x2, x3, or s1, s2, s1, s2, s3 within a tuple. That's a form of vector that all comma delineated form, I believe. And then that's the same thing as a column vector in which the first entry is x1, the second entry is x2, the third entry is x3. That's another form of a vector called like the vector form or something like this, something like that. Something else. Elementary, no. Elements, no. Yes, something. Basics. There's these vectors known as some term for them. They're like the building blocks, in which it's E sub I, in which I equals the ith row, having a 1 and the rest being zeros. So you would have like 1 0 0 0 1 0 and then 0 0 1 if you were in a R to the power 3, and then through a linear combination you can get any other vector in the R to the power n via saying x, the column vector x equals e1 x1 plus e2 x2 plus dot 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 E n x n. Standard basis vectors, those are what those are called, those E vectors. And then column vector form is what I was trying to remember, that term. R to the power n, set of all ordered n tuples of real numbers. All right, that's it for today. Talk to you tomorrow. See you.